OK, hi. Yeah, as said, I'm Tim Ruffles. I'm currently working on a product called Reject.JS, which is a code quality tool for JavaScript. And today I'm going to be talking about handling lots and lots of asynchronous code. Big asynchronous processes involving lots and lots of inputs, going in lots of different directions, AKA callback hell. But I think we've got callback hell wrong. I think all the kind of typical blog posts you see where people start going on about callbacks being JavaScript's go-to and how you can't run anything complicated in JavaScript. As soon as you start using callbacks, it all turns into a big spaghetti code mess. I think they kind of miss the point. So in this, I'm going to be talking about how you can handle most callback stuff with just the tools you already know of JavaScript. And then we're going to be looking at what I think is the real callback hell, the real challenges of asynchronous code, and looking at some new stuff, some libraries, but also some new things in JavaScript that will help you make it simple again. So pyramids. Pyramids of doom do exist. I've been looking at a lot of code for Sidekick as kind of research for what people are doing in terms of their code. And it's out there. Like if you look on GitHub, some Node code has inline callbacks 5 levels deep. You know, there's no way you can reason about this stuff. It's just a nightmare. There's no way you could test this in a million years. There's really no need for this kind of callback hell. Like for most of the code that I see it for, there's just no need for it. In the simple cases, like something like this. So this is just some simple Express.js handler. We're getting a user. We're going to update their profile. We want to check out, do they have a profile already? Or are we creating a new one? So just all very simple stuff. If we were writing this synchronously, it would be super simple. If you start just starting out Node and you don't know any other way, you might end up with something like this. So we're handling errors all over the place. We've got quite a kind of deep stack of nested callbacks. We don't want to do this for 2 reasons. First off, it's completely untestable. And I personally find that codes without test is just not code. I don't really count that as code. That's kind of a hack. That's like an experiment. Without code, I just don't trust it, and I wouldn't really trust someone else's code. I certainly don't trust my own code if it doesn't have tests. So how do we test this code? Well, there'd be no way. We'd have to dig right in. So if you have a look at the 2 points, I've got these comments saying we can't test this stuff. There's no way of getting in there. It's inside a closure. We'd have to test the whole lot in one go, so all of those callbacks, or nothing. So we either have to stub out every little bit of our code there, or we're just going to have to give up and not test it. It's not cool. It's not doable. So we can't do this. So we just can't do this kind of stuff. We have to name all our callbacks and reveal them. So we either reveal them individually in the kind of no objects, just have loads of blobs of functions, just have a name so we can actually get at them with our tests, or we stick them in objects, and then we can get at them in a test again. So everything has to have a name. All your callbacks should have a name. You should be able to get at them and test them individually. And that lets us split up the input-output stuff, which is the complicated stuff, the asynchronous bit, with the simple code we have inside our handlers, which say, if I have an error and a user, what happens? If I have a no error and a user, something good happens. All that kind of stuff. It suddenly becomes easy again as soon as we do that. Reason B, JavaScript already has tools to avoid most of the simple case kind of causes of complexity. So the named functions, obviously. But secondly, the function.bind. So how many of you have used function.bind? Cool. OK, so most of you. Well, function.bind is a really, really nice little tool that lets you get a new version of a function that's kind of partially filled in. So let's say if we have a look at the save profile method here, it has 3 bits of context. We're kind of going halfway through a process, so it already has the user. We've already got the user, and the next bit of the process, we either get an error or a profile. So if we were doing this all in line, we'd obviously just reference the variables in the closure, but as I said, we can't do that. We can't test it. How can we get around that with bind? Well, we can use bind. We pass it this, which is the context of this inside the new bound function, and we pass it some of the variables, which kind of fill it in. And we get back what's called a partial function, which is exactly that. It's like a new version of the function where one of the arguments has already been set. And that's what you get. So we've avoided using closures and therefore the untestability just with pure JavaScript. So bind kind of fills in the stuff. We get this partially bound function, and we can apply it easily. So it's nice and simple. It's not ideal. If we have a look, we've got our 2 kind of solutions to this. We've got naming, so we can test. We've got bind, so we don't have to use closures. We obviously have to percolate this context down in our functions. It's a little bit fragile. If we need to change the context, we're all doing it by hand. So it's OK. But we've won, haven't we? We've finished callback hell. Not exactly. These simple cases that people in blog posts say are completely insoluble definitely have solutions. But there's still pay points. So what happens when we have lots and lots of asynchronous stuff? Let's say we have a list of files. We need to apply some transform to all of them asynchronously. Or in this case, we have 2 processes we want to run in parallel. Well, bind can't help us there. Naming is not going to help us there. We need to have some kind of way of saying when both of these things are done, progress. OK? JavaScript doesn't give us any tools natively to do that. We're going to have to start writing them ourselves. We're going to have to start implementing this flow control ourselves, which is not ideal, because every single time we do something, we're going to have to write some of this kind of ad hoc code. Same with sets, so enumerables, all collections of things. So for all the users, do this asynchronous process. For all the files, do this asynchronous process. Again, you can see this is all very ad hoc code. I've just got this done, counting how many of them we've finished so far, and then finally it does the callback with the array of the outputs of this asynchronous process. So it's a bit of a pain point. We're writing code again and again and again to get around some kind of problem. There's something wrong with our code that makes us continuously have to write this ad hoc code to solve it. Well, maybe we could just get someone else to write the code for us. We can see these kind of patterns coming up again and again. Someone else must have had this problem. And indeed they have. And they came up with something called async.js. Ooh. So HTHJS is a nice library for Node. All the concepts in it could easily be applied to any kind of callback scheme. So when I say Node, I mean the Node callback scheme, in that you have an error parameter and then result parameter in your callbacks. You could change it for other ones. And basically, it's all the code you'd otherwise have to write if you wanted to solve these kind of problems. So it replaces your ad hoc code. It's a library of code. Doesn't do anything special, doesn't require any crazy language extensions. And it handles all the kind of patterns you might see. So a chain of processes where each function's output goes into the next one. Exactly the same as compose with synchronous code. It has a kind of a dual in asynchronous code. So we're waterfalling down the code. Or we might be talking about parallel, as I was saying. So when all of these callbacks have fired, give me this callback and have all the results in it. Or we might be talking about enumerations, so mapping over files, all that kind of stuff. As I said, it relies on this interface, this error result interface. It could rely on another one if you wanted to rewrite it. The kind of concept it's going on is that we can replace the manual ad hoc code by using an interface and just writing a whole library around it. So it's not going to do any good for you for browser stuff unless you do some adapting work. Now the problem for me with async.js is it is still an ad hoc solution. It's just someone else has written a bunch of code using the ad hoc solution. It's still a leaky abstraction. And what do I mean by that is, if it doesn't have a helper for your precise situation, you're still going to have to write the ad hoc code. So in our simple example, we had a fetch the user, fetch that user's profile, and then using both of those bits of information, do something else. So the fetch the user and then fetch that guy's profile is a waterfall. It's a chain. But then taking both those bits of information is a parallel thing. We need both those. And if you look at the signatures for those functions, unfortunately, we can't do them both at once. There's no helper that does both at once in async. So we're going to have to go back to some kind of ad hoc code to sort that problem out. And this is, to me, this is a classic example of a leaking abstraction. We still haven't solved the problem at its root. We're still having to write more and more and more and more and more code. And async's quite a big library. It's not just one simple concept. It's basically a bunch of hairy code covering all the different edge cases. What is the root problem I'm talking about? Well, what is causing all this hairy code? Well, I think it's the fact we don't have values when we use callbacks. So when you call a normal synchronous function, you get something back. Regardless how long it takes, could take 10 minutes, could be blocking for 10 minutes, but you still get something back before the next line of code executes. And that means we can do things with that value. We can use if statements, we can for loop over it, all that kind of stuff. But we can't do anything in our programs with a value that doesn't exist yet. And that's the problem with callbacks. It replaces values with flow control, as in we jump around the program. We don't have a value that we can kind of use in our programs. It just doesn't exist yet. Everything's kind of easy with values. So this is a synchronous version of our process. You can see it's just kind of programming 101 stuff. It's really, really, really simple. And that is our process. The asynchronousness of it is not inherent. if you see what I mean. It's just an implementation detail. It could be this simple if our language was good enough. Can we get values with async? Is that possible? Well, it is. There's an abstraction called promises, or futures, which has been around for a while. And the basic concept is, rather than a callback that kind of flies over your head and you kind of don't know where the value is, it gives you an IOU. And that's a value you get back straight away. So rather than, as I say, taking a callback and kind of jumping somewhere with the value in a future point, it gives you an IOU, piece of paper saying, I owe you one user. And then you can do stuff on that value. So just like normal code, you get your value straight away. And the basic API is, it's later fulfilled, as in the user has appeared, or rejected, as in I couldn't find the user or there was some error in the process, exactly once. And the other idea is it doesn't matter when that happens. So if it happens immediately, and you attach your callback later, or your request for the value of the promise, it doesn't make any difference. So it takes time out of the equation. It's a lot more like linking up cells in a spreadsheet when you're using promises. And then the second really important idea is that if you apply a function to a promise, you get a new promise back, which is a promise for the transformed value inside that promise. So they chain. So we have a look over here. We've got a promise for A coming back from our getA function. And then we use the promise for A, and we say then some callback. And that will return a further promise for value for B. And we can see the comparison with a standard callback interface below. So this is the bit where it gets really useful. So we've got get A, then, and we've got a function over A, and we're saying return get B. So that whole chain, this chains, just like jQuery or lots of other libraries, now returns a promise for B. And we can use that in future bits and pieces. The basic API is just this then. So you can see the direct comparison. We've got the promise for A, then, callback, and error back, versus the callback method where we have... Thanks. Useful. Cool. Yeah, so and then the callback version, we have the error and then the value. So there's a very kind of tight parallel between those two APIs. So it chains. As I say, that promise is the core idea. One of the two core ideas, I think, of promises is that it chains for reasons unknown. jQuery's API implementation doesn't chain, so it's not really a good implementation of promises, so I'd avoid that like the plague. And yeah, they just make things really simple again. So if we have a process here where we're kind of threading through, so this is from a project I did called Tweedar that was like a machine learning Twitter client, and it needs to get a tweet, and then it needs to format the tweet, and then it needs to run a classifier on the tweet. And you can see that process kind of gets flattened down. We don't have any real complexity there. And the whole process returns a promise for the final value. So we got the Twitter next tweet gives us a promise for a tweet. Then when we get the tweet, we put it through the formatter. That's a promise for a formatted tweet. And then we get a promise for a classified tweet at the end. And because there's no real reason we can't have multiple consumers for one promise, it's easy to tag on operations like logging, whatever else you need. You can chuck it out, and everyone can get it. So if we have a look at the earlier thing where we're having multiple dependencies, because we don't worry about time anymore, we can just get the first thing. We can, before we even have it, we can pass it into the process that takes the first thing, and then we can use some method like all to pass both of them on to a third process without any nesting. It's just super easy. It's completely uncoupled to time. We can already start reasoning about stuff that hasn't come back yet. Whereas with callbacks, we'd have to be doing all this threading via flow control, a lot more complicated and manual. Interestingly, it works with a lot less library code. So if we just have promises, we don't do any other code at all. We just implement that two-function API, the then thing. We can start doing really interesting stuff because we can, here we have a map over 3 files. We return a promise for the contents of the file, each one, and we map over the promises. So we now have the final function here is we get a variable contents that contains a promise for the contents, and we can return a new promise which is a promise for the transformation of that content without any additional library code. Because it's a value, it works with stuff like maps. It works with every other possible enumeration function you can think of. It's already there to play with. So we don't need to do anything in particular. We can make it even better with libraries, but I think it's a much happier abstraction for that reason. And you'll see throughout the talk from this point on, I think promises solve that one problem that you can never get away with if you don't have a value, which is you can't talk about stuff until it appears with callbacks, whereas you can with promises. So have we won yet? Well, we seem to be doing pretty well, but I'd say we still haven't won. We solved one core problem with callbacks, but I reckon there's another one. Also, two kind of pointers with promises. You need to ensure you catch all the errors. So when you do the then, promise doesn't have any idea of if you're finished yet. And so it will just soak up all the errors in the rejection handler unless you say .done in most libraries to say, like, from this point on, just throw the error if it's there and it's not being handled. So do make sure you do that. And you still have to unwrap them. So JavaScript has all this great stuff like tries and catches and for loops and things that we just can't use with asynchronous values, whether they're promises or if they're callbacks. We can't use them generically. We have to unwrap them from their process. So they either have to come into the callback and we get them out of the callback, or we have to unwrap them from the promise and then use them. So we write a lot of additional craft where we're effectively unwrapping the async value from the asynchronous process and then putting it into our ifs or our fors or whatever. It'd be really nice to just be able to use things like tries and catches and ifs and else just straight on the results of asynchronous values as if they were synchronous. That was what a language that was designed for async would look like. Like, why make it more complicated than it already is? And I think this is the kind of irreducible hell of callbacks, is that we kind of break JavaScript. All the JavaScript we know and love, we can't use with this stuff. We have to unwrap, and then we can finally get to it. We can't just use it natively. But there's a pretty cool concept called await. This is some kind of pseudocode. Imagine a language that supports await. Languages that do support await are things like C#. So we have a try and a catch, and we await the result of an asynchronous callback a couple of times here. So we can say, OK, if A equals await the capital A, so we've got some asynchronous stuff going on, and it's just going to stop at that point. Nothing's going to happen, and then it will come back. So we're using asynchronous code. It's asynchronous implementation. We can run loads of async at once. We still have the performance of async, but we get back a synchronous-looking code, which is great, because a language is not as implementation. It doesn't matter if a language looks synchronous as long as the async I/O is still going on in the background, so we can support lots and lots of users and all that kind of good stuff. So could we possibly do this? I mean, we can't really do it in JavaScript, surely. Surely this is the end of JavaScript. Do we have to use some kind of new crazy language that compiles to JavaScript, or just give up? No. JavaScript has a new trick up the sleeve, coming very soon. We had a talk about ES5 today, but now we have ES6, or we will have soon, hopefully. So there's a concept in ES6 called generators, and this will let you do, I'm sure, a load of really cool stuff that no one's even thought of yet. But one of the really exciting stuff it does is allows you to write code that looks like synchronous code. So before we go any further, I'm just going to talk a little bit about generators. They're in the draft ES6 spec. That's supposedly going to be finalized December this year, unless anyone's heard an update from that. It's in the draft, so it's kind of, if the spec gets approved, it will be in there. And it looks like this. So it has a little star operator next to a function to say, I'm a generator function, or a generator kind of constructor. And it has the yield keyword. Now, what yield does is at that point, it returns control back to the calling, whatever's calling the generator. So you can kind of think of it as kind of intermediate return. And it pauses execution inside that generator. So we won't go on to the next line of code until the generator is resumed. So we literally pause at that point. So if you go have a look at this code here, we have a while true loop, which is never a good sign in code. You see a while true loop in your code, you're thinking, oh, this is a bit of a nightmare. But it works fine with generators, because we control when it's resumed. Every time it hits that yield inside the while loop, it's going to return control to the calling environment. And it's not going to go around the loop again until we hit next. So it's kind of like we can pause and play it again. So it lets you write things like, I don't know, things that generate long sequences of code of numbers or something extremely nicely and concisely. And you can see the API here, as I said, it's a kind of generator constructor. When we call it, we get back a generator. We get an instance of the generator. So we call it first count. Now we have our counter. It's the generator itself. And then we call .next on it. And then we get back a kind of tuple-y thing. It's an object with two keys, value and result. And then we can have a look at the, value and done. And we can have a look at the value, see what we got out, and that will be the thing that's been yielded. So it's kind of like the return keyword in that respect. And we also have a done, and we can check if it's done. And basically, if it's done, it's fallen off the bottom of the generator, just like normal. Cool. So what does it look like? Let's have a look. So here is a thing called 3 queries. You can see it's relying on some glue code that we're going to have a look at in a bit, called a waitable. And we've set up 3 queries, A, B, and C. We set ourselves a result array. And then we're just using the standard JavaScript. I know, not quite the standard. This is just a gratuitous ES6 demonstration. It's using the for of, not for in. So we can just go straight over an array without any indices or anything. Very cool feature of ES6. So we're going over the whole array of our promises, and we're just hitting yield, and that's going to block at that point. We get out the generator, and then it will come back when the promises has been fulfilled. So you can see that this is parallel. We've done all the queries. We started off all the queries on the first 3 lines, so they're all going in parallel. And then we're going to block on them all until they're all done, and then we're going to return the result array. So it's very concise and clear, but it's also very fast, because it's parallel, async. Good combination. Cool. Now this is the point I have to like, ooh, can I actually explain this? How does this actually work? Well, proviso, this is a black box. The way you do the generator implementation, you can kind of ignore it, or you can understand it. It's not very difficult. You can either do this with promises or with callbacks in the same way. If you have an interface for your callbacks, you can do this with callbacks too. I think generators with promises are a little bit more powerful for a reason I'll explain in a second. But let's have a look at how this works. OK, so this is the queue.async function. So this is the thing that, given a generator, returns a kind of awaitable one. So generators, as I said, could be used for loads of different things, not just this. But we're going to use a generator for this await style keyword. So we get our make generator function, and we return a new function that's the kind of decorated one. Now, we set up a continua function that takes a verb, and we're using bind again. So it's lucky I talked about that. We make 2 versions of the continua function, one that's going to go next on the generator, and one that's going to go throw on the generator. And the next one just resumes it, as we've seen before. OK, so we start off just by calling the callback, which is going to go into continua. The verb's going to be next. It's going to ask for the next result of the generator, so it's going to run until it hits the first yield, and then give us back the promise. If we throw an error at this point, then it's going to return a rejected promise. It's fine. If the result's done, we're going to return the value of that entire process. But the important bit really is, if it's not done, we're going to say, queue up that promise, because it's yielding promises every time. That's the whole idea. Queue up that promise, and when it's done, if it succeeds, we hit callback, so we loop. And if it fails, we hit error back, so we throw. Now, throw is really super. Because throw, I hope I have a try-catch example in here. Yeah, here we go. It's not even JavaScript. It's a bit unfortunate. But throw will literally throw an error from that point inside your generator. So suddenly your asynchronous processes work with try and catch, which is completely amazing. You can suddenly granularly put a try and catch around each one of your async processes that might fail. Again, you can use try catch. It's pretty amazing. Cool. And that's it. That's all you need. And the glue code for using it with callbacks is even shorter. It's amazing. And like I say, I mean, this is just one use of generators. They're going to be pretty amazing. So having a look at a dependent process, we can just yield A, wait for it to come back, and then put it into B. It's just like synchronous code. We get the value back. Parallel processes, as I said, are pretty easy. We just kick them off. We get the promises from both, and then we can just loop over and block. Now, the point I was making about callbacks is you still can't do it like this with callbacks, because we're still going to have the same problem where we don't have the value yet to reason about. There's nothing in the machinery that's going to let us give back something, so we're going to have to block on the callback straight away, just one at a time. So you can't do parallel processes with just callbacks, but you can with promises. Enumerable is pretty easy, just looping over arrays. And obviously, this all works with async as well, if you're using the callback style. Sweet. So, seems like kind of asynchronous code is a solved problem. Well, the last thing that we can't do with async, and I don't think we're ever going to be able to do, is to wrap the async bit of our code and ignore it from the rest of our code. So we have a synchronous bit of our code and an async. Because we can never stop the asynchronous code kind of leaking out. We're always going to have to deal with async code everywhere in our code base. And that's simply because JS is always going to be single-threaded, and there's no way of having what are called a deep coroutine where we block the whole thread. All the generator does is go back to the calling environment. It doesn't block the entire interpreter. And this is a good thing. If we had threads, we'd have all the kind of problems with threading that we don't have with JavaScript. So it's actually good. This is the kind of level of pain we should accept in JavaScript. We have synchronous-looking code. It's pretty easy to reason about. I think we won. I think we've won. Asynchronous code is kind of easy again. It's pretty exciting. So we've got JavaScript back. We can use ifs, we can use elses, we can use fors and tries and catches. It's all pretty easy. We need to wrap our code with these kind of glue code things and use generators. It still leaks the async everywhere in our code, but we're happy with that. We avoid threading hell, which I think on balance is far worse than callback hell. Cool. So to sum up, don't inline everything. It's terrible. You need to write tests. JavaScript has the tools to solve the simple cases. And when they fall down, we have our kind of trio of tools. We can use async. It's pretty good. It's not a great abstraction. It kind of leaks. And when it leaks, we can use promises. Promises also solve the whole time issue. We finally have a value game. We can write code straight away. We can kind of link it all up like a spreadsheet. And then finally, if we want to write some really nice-looking code, we can use generators. You can use generators right now, by the way, in Chrome Canary and Node 0.11 with the Harmony flag. And they're coming pretty soon. There's also a tracer compiler that compiles from ES5 to ES6. It includes generators by some crazy voodoo. So you can use it today. And Firefox, but is it still the Python generators? Or? Yeah, I thought it was. Sweet, OK. So Firefox soon. Firefox currently has an old version of generators, but it will soon have the best version of generators. Thanks a lot. Cool. That's me. Come ask.